Hello Math 1093, this is Dr. P with Formula Fitting. In the previous video, Signs of Progress, I gave you a modified sine function. We talked about how you find its graph, either using transformations or just by analyzing the amplitude, midline, period, and phase shift from the formula. In this video, we're going to do something a little bit different. I'm going to give you a graph, which is the one shown here, and we're going to find a formula. We're going to find a formula for a sinusoidal function that produces this wave. All right, what does sinusoidal mean? Well, sinusoidal just means any function of the form a sine of kx minus c, there we go, plus b, or a cosine of kx minus c plus b, where a and b and c and k are all real numbers. Those are sinusoidal functions. All right, so how are we going to do this? By the way, notice I said a formula because there are actually many formulas that would produce this same graph, many formulas for the same function, and I'm just going to find one formula. So I'm going to try and let you know when I'm making a choice that could have been made differently. The first choice I'm going to make actually is I'm going to decide whether to use a sine or cosine function. And there's actually a little bit of strategy to this. All right, so in this particular case, my attention tends to be drawn to maxima and minima when I can tell what those are. So for example, I have a maximum at -1, 3, and I have a minimum at 1, -2. If my attention is drawn to maxima and minima, a lot of the time it is useful to use a cosine function because cosine functions are sort of anchored at their maximum and minimum points. Like this is your typical cosine function, and then everything else is a transformation of that. On the other hand, if you find yourself drawn to the midline points, by the way, where is the midline for this function? It looks like, well, it's going to be halfway between 3 and -2. So what would that be? 3 plus -2 over 2. I'm just taking the average of those would be 1/2. So the midline would be at y equals 1/2. See if I can get that somewhat straight. There we go. That's the midline. So if you happen to know where the midline points are, and you actually can find them in this picture, you might find it convenient to use a sine function instead because sine functions are anchored at the midline, like this. And then any phase shifting that we do is going to be relative to one of these pictures. So I'm going to pick the cosine function as our base, and then we're going to modify that. All right, so we're going to start with a cosine function, which means we're going to have a formula that looks like f of t equals a cosine k x minus c, c is our phase shift, plus b. And we need to figure out what all of those values are. We also need to figure out whether there should be a plus or a minus sign on the a. That'll depend on whether we think we have vertically reflected the graph or not. So here's what I'm going to do. I'm going to choose this point here, -1, 3, as an anchor point. All right, so what that means is I'm going to imagine taking this whole graph here, the one that you see here, and just shifting it over a little bit to the left in order to get this maximum here over to -1. So I'm going to write that down. My phase shift for this is going to be -1. All right. What else? What about the amplitude of this wave? I can tell that from looking at the picture. The amplitude, well, the midline was y equals 1/2. I mentioned that first because that makes it easier to find the amplitude. If the midline is at 1/2 and the top of my wave is at 3, well, what's 3 minus 1/2? That means the amplitude is going to be 2.5, which I'll just call 5/2. All right. So I've got the phase shift, the amplitude, and the midline. Now I just need to find my period. Well, the period is going to be the distance horizontally between any two maxima. And in this case, that looks like it's going to be, let's see, this is the point 3, 3. So it looks like this is a period of 4. So now I just need to take all this information and turn it into parameters for this function. Well, if the amplitude is 5/2, that means that the value of a, which represents the amplitude, is just 5/2. If the phase shift is 1, then that means that my c is -1. But of course, keep in mind, I'm going to be subtracting that here in just a second. The midline is y equals 1/2, so that means that my b is going to equal 1/2. It's the period that's a little bit tricky. This does not mean k equals 4. And that's because, you may recall from our earlier work, that the period of one of these trig functions is given by t equals 2 pi over k, where k is that magic number there in this formula. All right, so if the period is t equals 2 pi over k, and my period is known to be 4, then that means that 2 pi over k has to be equal to 4. If I solve that equation, I get 4k equals 2 pi, and then k equals 2 pi over 4, which is pi over 2. So that means that my k needs to be pi over 2. So putting all this together, I get the following possible formula for this wave, and we should verify this. I'm not going to do it here because it's not easy for me to pull up a graphing utility in this video, but you should do it yourself, okay? So my f of t is going to be a, that was 5/2, cosine of pi over 2, x minus -1, so that's x plus 1, plus 1/2. And I think that will give me exactly the wave that I produced over there. But again, you should check that. You should use a graphing calculator or Desmos or something to verify that that is the case. Okay, so that's an example of how we go from a graph to a formula, from this graph to this formula. The way that we did it was we knew that this formula would have to have some parameters, these 4 things, A, B, K, and C. And those would be linked to these attributes here. By the way, I did not put a negative sign on the A because the point I used as my anchor point was the top of the wave. Had it been the bottom of the wave, I would have needed to do some kind of reflection. But usually you can organize these so that you don't need to do that, because if you see the graph, you're going to see a maximum point. That's why I kind of prefer to use cosine functions over sine functions personally, is I can usually pretty easily spot where the maximum and minimum are. Anyway, so what do? We just took some measurements, measured the midline, the amplitude, the period, and the location of this maximum point here, and turned those into parameters. And that's the idea.